Alright, so do you guys have a sketch? No? Okay, then I'll hold off for a minute. So if everybody put all 5 trials up here, including me, there's 9 of you today, and me, we have 50 dots up here. Right? 9 of you, and then me, to make it a nice, even, pretty number. So what we're going to do is we're going to find out what percent of the class's trials did the difference in proportions equal or exceed. So not just the ones that are equal to 0.04, but the ones that are also bigger than 0.04. And then use that result to decide whether yawning really is contagious. So here's 0.04, right here, that big, tall stack of dots. So we had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. Ooh, that's a lot of them. 33 out of our 50 little experiments got 0.04 or greater. So based on our class's simulation, how surprising would it be to get a result this large or larger simply due to chance involved in random assignment? 33 should be 66%, right? 66%. Thirty-three out of 50 is 0.66. So 66% of the time we got 0.04 greater. So do we think that 0.04 is statistically significant? Yeah. Yes. A difference of 0.04 is statistically significant. So what would we say about yawning being contagious?
It is.
It is. At least we have math to back it up, unlike the silly Mythbusters. They just looked at it and went, yeah, sounds good. So maybe sometimes they're wrong. Yawning. Hey. I can't. I'm not sure that the district would be okay with me if I put people in boxes for 5 hours. So, no. But it took them 5 hours. That's what they said. 5 hours and 50 people later. I'm not sure. Although at the end of the year when you guys do your projects.
Can I put someone in a box for 5 hours?
Maybe. Can you pick Chase?
Yes.
To put in the box for 5 hours?
If you put a breakfast burrito in there with him, he'll be fine.
Each person was in the box for 6 minutes.
Really?
Yeah.
I don't think so, because they had 3 boxes, and it did say, when they didn't talk about it, but it did say below where it said if they had the yawn seed, 29% yawned. It said if they had the yawn seed, the average amount of time until they yawned was 9 minutes. And if they didn't yawn, or didn't have the yawn seed, it took them 9.6 minutes until they yawned. Now I wonder if that's a big difference. There were 3 boxes. All right, so like I told you guys in chapter 10, we're going to be comparing 2 groups. So comparing 2 proportions, comparing 2 means. So we have already talked about sampling distributions before. That was chapter 7. So for a sampling distribution of p hat, we have our normal curve. What's at the center? P or p hat? P. And this is p hat sub 1. So at the center would be p1. The statistic is when we use p hat. So from our sample, we use p hat. Parameter is just p. That's from the population. And then if our statistic is a good statistic, unbiased, low variability, the mean of our statistic will be our parameter. And to find the standard deviation of a proportion, it's the square root of what? P sub 1 times 1 minus P sub 1 all over, and I'm going to call it N sub 1 because it's the sample from our, or the sample size from our first sample. Okay?
So on the test, there was a question like this where it didn't tell you the mean. The mean is the same as the parameter.
Should be. And then you always label, it's normal. And to be able to label it normal, what is the condition we have to check? What is the normal condition? N times P is greater than or equal to, and N times 1 minus P is greater than or equal to 10. So, because in this chapter we're going to be looking at 2 samples together, and so we have to delineate between sample 1 and sample 2. And then sampling distribution of p hat sub 2, same thing, but we use p sub 2. The statistic is p hat sub 2, parameter is p2. The mean, again, if it's a good statistic, it should be your parameter. Standard deviation is the same formula, just with p sub 2 and n sub 2. And you have to check the normal condition. I'm not going to rewrite that, but you would have to check that also. So that is stuff we've already done this year. What we're going to do in this next chapter is we're going to look at the difference. Can I move it up? I'll leave that one there. So this chapter, we're going to look at the sampling distribution of p hat sub 1 minus p hat sub 2. So at the center of that distribution should be P1 minus P2. The statistic would be P hat 1 minus P hat 2. Parameter P1 minus P2. Again, if we have a good statistic, our parameter is at the center. Now the standard deviation, that formula changes for this chapter. Not really changes, but it changes enough that it's slightly different. So we're still, I'm going to write it below because I write way too big to fit it on that line. Still going to take the square root. We're still going to do p sub 1 times 1 minus p sub 1 all over n sub 1. And we're also going to do the p sub 2, 1 minus p sub 2 all over n sub 2. Now, Back in chapter 6, we talked about how to combine two standard deviations when you're looking at the difference or the sum. And remember, no matter if it was difference or sum, you add them together. And then technically this should have the normal label. And we're still going to have to check our normal conditions.
Write that whole thing.
You can draw an arrow. So tonight, your homework is 3 questions, and it's... Oh, I'm sorry. 3 questions, and it's going to be about how you subtract and find the standard deviation, that kind of stuff. Now,